someone requested, what about if I'm working with LiDAR data, but I don't have good channel information, all right? So I'm going to work through an exercise, and I'm going to have you guys go through the same exercise. Unfortunately, I don't have it in the book, so you're going to have to be alert and kind of observe what I did, and then you guys can do it. Fortunately, most of the model's set up for us. So I'm going to go ahead and open it up on our computer. If we just start a second project here, so we go to File, Open, and in your training exercise, you see one called number 4, Survey Data Processing. If you want to go and open it with me, that's fine. Just open up this one called Brock Creek. It's a flood project in Oklahoma City, Oklahoma, and it'll load up on your screen there. Okay. Well, anyways, you'll eventually get to here. So this is Oklahoma City, Oklahoma, home of Will Rogers, if you're familiar with that area. So they flew the whole city. They processed that LiDAR data. I think the LiDAR data is missing on your models, but maybe that might be the issue. I think it is. So the original elevation grid was processed with LiDAR within our software. So you can process the LiDAR data directly within here. You can, of course, do it in Civil 3 as well. So if you go to Map Edit, you scroll way, way, way over on the far right side. You guys just watch me. Maybe you'll get more out of it. If I click on Process LiDAR Data, you can bring in your LiDAR data set. I'll show you an example how to process LiDAR data. We'll go and create a third project. And I'm going to say Add Elevation Layer. I'm going to go and grab a different folder. You'll see one here called LiDAR Processing, number 7. So in here, I want to grab my LAS file. So it's a laser scan file. There's either LAZ or LAS. It supports both. Click on OK, and you'll see that data coming in. Now, in this case, it's coming in meters because the original source data was in meters. But I can change those units easily enough. Go over to File, Options. You see it defaulted to metric, but we're working in the US, so we're the only country, other than I think Bosnia or some place that does feet. Everywhere else has gone to metric. So anyways, you'll see an area there. Now I thinned this down so it loads quick because the original LiDAR file is pretty large. But if I go and add a base map, just right click, say Add Base Map Layer, throw in the Google map, hit OK, you'll see your contours. This happens to be Lake Tahoe, just outside Sacramento, north of. This is a landlocked lake, so there's no rivers flowing through it. It just, everything is, the watershed for this is all held in by the drainage areas, so everything drains to it. So and it's a fairly deep lake, and at times you could see it clear to the bottom, but now it's filled up with algae. In fact, you can see some algae blooms in there. But anyways, we want to go ahead and process this LiDAR data. So if we go over here, I can right click and say Zoom to Layer Extensive, zoom back to where it is. Okay, so I want to go and save this. It's going to want me to save the file. But if I try to do anything, it'll complain. So let's just see what happens here. So if I go over to my map edit, say Generate Terrain, it says I got to save my work, right? So hit OK. All right, let's go put this in my work folder. So I'll go back into my tutorial folder. And this was for our LiDAR processing. And we'll just call it, I guess, Project 4. Oh, that makes sense. Save it in there. Okay, so it's saying, okay, you're using LiDAR data. And I can trim it down if I want. I'm going to save this as an elevation grid. So here I'm going to go and call it 3D terrain. I'll overwrite that old one. And it's saying I can go down with the amount of memory in my computer down to whatever 600ths of a foot is. So I go ahead and choose like a 1 foot cell size. That'll generate about 6.9 million cells. Click on Generate. It's going to go and build my terrain model. So now we can go and colorize that, right? I can turn off this merged, and if I come back over here to our properties, I can say elevation color fill, and if I change the draw order, you'll see it showing up there. Okay, so that's our data. Of course, now you can contour it. People had some issues. A couple people had issues with contouring. I don't know. I've got your data set. I'm going to go and take a look at it. But anyways, go and save this on a computer. Tell it the resolution you want or interval here, And I'll just say terrain surface limits. It'll detect what the limits are if I forget to do that. Hit generate, and it's going to create my contours. Now you'll notice that the contours are really kind of squirrely here, so we can smooth that a little bit. We'll go back in there to contours, and you'll see here there's a smooth option. This thinning also removes any redundant vertices. You can see quite a bit different. I'll show you what this looks like. Let's go back and just generate it without it overriding them. If I come in here and select one of these contour lines and press function key F4, you see there's lots and lots of contours in there. Right? There are lots of vertices in there. Now there is a smooth command in the software. You can go over to your smooth elements. You can choose smooth elements, and you can set a threshold and smooth it there. But an easier way is just to have the software do it. So when we go back into generate contours, if I turn that thin contours on, hit generate, it takes a little bit longer to run. But I don't remember which one I selected, but let's try that one. We'll say edit vertices. You can see it's removed out a lot of redundant vertices in there. But we want to smooth that, right? We want to take out some of the garbage that's in there. So we can go back in there, generate contours. We'll say smooth contours, hit OK. Now what it does is it basically looks at each cell and the surrounding cells around it and smooths the grid. So it creates a smooth grid. You don't see it here, but smoothing the grid first before it contours it. Click on generate. And there, now let's see our contours a bit smoother there. You do lose a little bit of precision in some spots, but I don't think you're going to notice it because you can see that's about 100 feet in there. I doubt if we're going to see any difference there for what we're doing for our civil engineering work. So if we go back over here, we have this elevation grid. If we take a look at that grid here, this LiDAR was processed within the software, and we have a 10-foot by 10-foot cell size. The reason we chose 10 foot is just that seemed reasonable based on the LiDAR data that we were given. The problem, though, is that Oklahoma City is so flat that they have the drainage ditches all over town. There's this one that I put in here, and there's another one up here, and there's a few other ones. And if we zoom in to one of these drainage ditches, you can see they're about the size of a house, right? They're pretty big. And so, in fact, if I use my measure tool, this little measure tool over here, hit the little arrow and you can measure areas or distance. I'll choose distance. And I can come in here and just measure across that just to see what that is. And it's saying it's about, down in the status line, it says it's about 65 feet across. So I know a 10-foot grid won't have the necessary resolution for that. So I brought in these survey shots. Let me change the color here so we can see them a little bit better. I'll make them stand out a little bit better. And so I brought in these survey shots. And if I click on a survey shot, if I open my Data Explorer, click on the survey shot right here where it looks like there's some water. You see it says it's on the layer survey points, which is now highlighted. You've got a point number associated to it. You got a northing easting. That's basically a y-axis coordinate. You have an elevation and a survey code. See, it says channel center line. That's the abbreviation for it. If I click on the shot adjacent to it, it says channel. If I try some place over here in the overbank, you see it says, what does it say here? It says ground. If I click on a shot right here, it says top of bank left. Click on the shot right adjacent to it, it says total slope left. So it's not, it doesn't seem to be corresponding exactly with that imagery, but it's close. If I click on this shot right over here, it says it's a bridge pier. So some of this stuff I know what it is, some of it I don't. The pier might be a low chord or something. I don't want to necessarily use that. But anyways, the part of the problem is, and let me change the color again so it pops a little bit more. Maybe make them brighter yellow or something. I don't know if that's any better. But anyways, you can change the sizes and things like that. But what I want to do is have those survey shots snap onto that line. Now they did I've done surveying in the past, and I've never been able to hold a line that accurate, so I don't know how they shot that so accurately. But still, it's not exactly along that line, and you wouldn't want to use those points as this cross section because they're not straight, right? So I drew a little red line through there, kind of representing where the section might be, kind of like through that set there. And there's another set here. Of course, there's all over the place. I skipped some. You can see that's like a top of a road or something. But I want to basically use the survey shots for my section. So what I'm going to do is I'm going to go over to my input menu. Under cross sections, I'm going to choose here conflate point data. It's basically going to take the points that are on there and collapse it onto our cross section. grab our cross sections here. We've got 32 of them. I want to grab my point source. So in this case, it's a GIS point source, but we could read from a CAD drawing. So if you had COGO points in your AutoCAD drawing or 3D points, it'll read that. Or an external ASCII point file is commonly used if you have a data collector. In this case, it's GIS data. And it automatically figured out, for whatever reason, it figured out, that this is probably the layer to use. So there were some other layers in here, but it sorted those out, and it mapped the attribute for us. In my case, it figured out the survey code. In your case, it may not. But then I have to go and tell it what data to read it. So we want to read it in the channel and channel centerline data. I want to go ahead and bring in the ground shots. So this is alphabetical order. So I want ground. Then I want to bring the bank information in. So here's the top of bank, left and right stations, and we've got a total slope on the left and right side. There's some other ones that are probably useful, but I don't know exactly what they are. These are the ones I'm aware of. Then we want to define how far away do we want to accept points. What is the buffer distance, right? So I could come in here and measure that. I could say, well, let's say from here to halfway to that nether section, right? I don't want to go that far out. Otherwise, it starts to scavenge points nearby. So I might say, well, half of that distance, like maybe right there. So here it's saying like, 10 feet. I rounded it up to 10 feet for me. I'm going to just choose 5 feet because I think there's some other sections that are in there. Now, if your section's skewed to the reach, then you may want to have them snap parallel to the river reach. So if your cross sections are not aligned with their cross section, you'd want to probably choose that. In this case, it's fine. And then we can go ahead and assign bank stations if we want. We can apply the entire section, or maybe you might just want to pull the data from the channel. Maybe the overbank stuff's fine, but maybe you just want to pull the stuff from the channel, so you could choose that. Select OK to that, and it will assign that information to our section. So if we come back in here, and if we right-click, say Edit Vertices, or press Function key F4, you can now see these survey shots have been snapped on that section line. If I go and take a look at this one up here, you can see it threw that one away, right? That's the one that has a pier in it. So, and there's another one with a pier. So some of this stuff it read in, some of it ignored based on what I specified. If I go look at this section now, I can see my geometry. And as I work my way down my river, I can see my geometry is changing, right? So now what I want to do is I want to take this LiDAR data, which is highly accurate, or the survey data, which is highly accurate, and I want it to interpolate along this alignment. Okay, so we want to have it follow along that alignment. To do that, we're going to go over to our Map Edit menu, choose Interpolate Geometry, and we can tell it to apply to the entire river model or just a piece of it. So if you had just a few sections you want to interpolate between, it'll do that. But basically what it's going to do is it's going to burn that channel into that elevation grid, right? So I can tell whether to do the channel and the overbanks, the channel only, what is the original source data I'm working with, what's the extent of data I want to process, what's the DEM file. So let's go and save this on my computer, and we'll call it, I want to make sure I'm in the right folder. So this is under Survey Processing, and we'll call it, I'll just say channel, so I know what it is, channel. Hit OK to that, save that. And then it wants to know what kind of resolution I want to work in. So I can go over there and override that. I could say, well, let's have a 3-foot grid. That'll generate about 10 million cells. So you probably want to maybe go finer than that. It's saying on my computer I have enough memory for 1 foot. I could probably get it tighter than that, but 1 foot is probably good enough. Click on Generate. It's going to basically linearly interpolate along that alignment. So it's taking and building and adding additional sections along there, interpolating as it goes, and then burning that into our terrain. And so now you can see my channels, my active layer. I can turn off these other layers here. And if I rotate this around into a 3D view, we should see that it has been burned into our channel. So maybe you guys can try that same exercise. I think all the files are there for you to go with. And I don't have it written out. I apologize for that. We have it on video, and but I'll walk around and help you guys work on this. So this will help you with integrating survey data along with LiDAR data. Okay.
I have a question.
Yeah, question. Go ahead.
Interpolation, does that only work the channel width doesn't change?
No.
One side was much wider than the other.
No. It will linearly you can have really broad section and then a very narrow section. It'll linearly interpolate between them.
I guess what I'm saying here, like if one side was much wider than the other, how would it follow that line?
Okay, I see what you're saying. So, yeah, here I don't know what it's doing here. It's probably not interpolating much going on there. But from here on downstream, it's going to interpolate all the way down to where it got to this one, right?
Okay, so it's interpolating between each.
Yeah, so it's burning. It's basically adding interpolated sections. You don't see that. It's creating a bunch of interpolated sections about, I think it's like 25 feet apart, and then it takes that and then it burns that into the terrain model.
Okay.
Okay. Now this is, like every tool in a toolbox. If the only tool in your toolbox is a hammer, everything looks like a nail. So be careful, not to misuse this, right? It's not, it represents, it does what it can, right? If your geometry is doing something like this, it's not going to figure that out unless you got sections for it. Other questions?
I do have a question actually about the LiDAR data.
Yeah.
About the accuracy of the LiDAR data. For example, for this example, we now are in 2020 in reality. If we want to investigate like flood event in 2020, so but we are using in LiDAR data in 2009. I mean, not for this example. I have a project right now.
Yeah.
That flood happened in 2016. But the person that used GeoHECRAS 2D used the LiDAR data in 1999
Okay.
to investigate like the flood in 2016. So, but it is like lots of construction. When I looked at Google Earth, I have seen lots of construction from 1999 to 2016. So he used the land use Maning's value from 2016, but the LiDAR data from 1999.
Yeah, you shouldn't be doing that.
My question is that, how much the accuracy of LiDAR is important to even look at the flood zoom mapping.
Yeah, so it's a good point. I'm not a surveyor. I was when I worked out in the field as a operating engineer running heavy equipment. I want to go back to college. I didn't have enough money to go to college first time, see? So I went and became a surveyor rodman. And back then, basically, that meant you hauled all the equipment around.
Yes.
And back then, the equipment was really heavy, They had something called an EDM, which was about the size of a small car. It seemed like it wasn't that big. It was about the size of a refrigerator. You set it up, and it would read how far away a point was. And that was like total wild, that was crazy. Versus you used to use metal tape, and you tape it out. You guys probably think I'm from the Stone Ages, but again, garbage in, garbage out, right? So if he's using 1999 data, that's not. He should go out there and fly it again. And you can fly that stuff now with these drones. And I taught a course in Albuquerque, and it was at a surveying shop, and part of that they wanted to sell their surveying equipment to these engineers. And so he took like an hour, and he flew his field that was maybe 5 or 6 acres. He flew it in 5 minutes, downloaded it onto his laptop, and we had a surface in like less than an hour in AutoCAD. So, the technology's completely changed, right?
Yes.
So he should have better data than that. Yeah. Okay. Yeah. Good point. So guys, if you can work through this exercise, that's exercise number 4, I think. And maybe you want to try number 7 as well, the LiDAR data.